Greetings again, and so welcome to lesson 5. So lesson 5 we're going to do question 10 again. So this time I have question 10, and this is from September 2024, and it's okay, well, it's not written here, but it's from Northern Cape. This is Northern Cape, and this is September 2024. So I hope everybody's doing well, and so let's get into lesson 5 now. So let's read the question together. It says what? The table below shows different metals with their respective threshold frequencies. So they show the threshold frequency this side, and then they say it's in hertz. So there's 4 metal types here. There's A, B, C, D. So they are all multiplied by 10 exponent 14. And they say light of frequency 3.15. And they say multiplied by 10 exponent 14 hertz as radiated on each metal. So in the first one, they wanted the definition. They say define the term threshold frequency. What is that? This is the minimum frequency. The minimum frequency of light that is required to emit electron from a particular metal surface. This is what the threshold frequency is, and then what the symbol there is what is F naught. It's the minimum frequency of light that is required to emit electrons from a particular metal surface. That's what it is. 10.1.2. Say in which metal or metals A, B, C, or D will the photoelectric effect not take place? And they say give a reason for the answer. Okay. So how can we tell? Isn't it here we must compare the frequency of light here should be compared to the threshold frequency. So we have to see where the threshold frequency is bigger than the frequency of light. We can see that 3.15 is bigger than all of these numbers from A until C, but then it is smaller than D. So it's going to be D. And then we're going to say here the frequency of the incident light. Incident light is smaller than the threshold frequency. So it is smaller than the threshold frequency. That is why there will be no effect here, photoelectric effect. And then 10.1.3. Then calculate the highest maximum speed of the ejected electrons. So in order to get the highest, they say the highest maximum speed. This means what? It means lowest threshold frequency. Because the lower the threshold frequency, the higher the maximum speed. So we check. We can see that we're going to use C here. C is the one that has the lowest threshold frequency of them all, 0.06. So we use the equation where then we have E equals to work function plus EK max, maximum kinetic energy. And so we use the frequency here because that's what we're given. We're not given the wavelength. So I'm saying HF equals to then H threshold frequency and then plus. So we're looking for the speed here. So we must rearrange this such that we have a speed here. It's going to be half M, then V squared maximum, then V squared maximum like this. And then if we want the speed here, we have to make V the subject. So then it's going to be, if we multiply by 2 here, it's going to be 2, then HF minus HF naught equals to M, then V squared maximum. We want to make this the subject. Again, we have to divide by the M. Then we take the square root. So if we divide by M here, it's going to be 2 over M, and then minus, then equals to V squared maximum. And then if we want the maximum, then here it's going to be V max. We take the square root. So then it's going to be 2 over M HF minus HF of. And then here we can take out the H because it's a common factor. Okay. So it makes things simpler. So to simplify things here, we can say first 2h over m, and then frequency minus threshold frequency. So the threshold frequency here we're going to use for C, isn't it? Because it's the one that's going to be the lowest. The lowest threshold frequency. So then we substitute. So it's going to be 0.06. So then we say 2 multiplied by, and then 6.63, 10 negative 34 divided by m. The mass here is a constant. The mass of an electron, then negative 31. Then the frequency here is how much? The frequency of the incident light is given as 3.15. Yes, it's 3.15 and 14. So it's 3.15, 10, 14, and then minus 0.06, then 10, 14, then equals to. So you use a calculator here. So don't forget to include the square root here up to the last number. Okay. So it's not just the coefficient here, which is the square root. The square root has to go all the way until the end. So we use a calculator here. And it gives me 6.71, and then 10 to the power 5. Uh, 10 to the power 5 and then meters per second. That is the speed. Okay. Then they say 10.1.4. If the intensity of light radiated is decreased, what will happen to the speed of the electrons calculated in 10.1.3? So what we're changing here is the intensity of light. The intensity of light has no impact, will have no effect on the speed, like I said on the first lesson, that the intensity of light will affect. So if it's decreased here, it will decrease the current. It does not affect the speed. So 10.1.4, the answer is it remains the same. There is no effect. Speed remains the same. The speed does not change. Ten point two, they say explain the formation of the atomic emission spectrum. So this is the key word here is emission. Okay, it's different from absorption. So absorption is the opposite of emission in this case. Okay, so what is the information of atomic emission spectrum? Okay. So uh, emission spectrum. This how do you explain this? So I'm trying to find a proper way to explain it. So here, and three. So this one, it is formed. It is formed informed when certain frequencies so it is formed when certain frequencies of electromagnetic radiation electromagnetic radiation are emitted due to an atom making a transition from a higher energy state to a lower energy state. So this is because we were asked about emission here, not absorption. So if it was absorption, it would be is formed. Oh, yeah, is so it is formed when certain frequencies of electromagnetic radiation are emitted due to an atom making a transition from a higher energy state to a lower energy state. So if it was absorption, okay, as in this case, we were asked about emission. So yes, if it was absorption, it would be the opposite. So we would say from a lower energy state to a higher energy state if they asked about absorption here. Then everything would remain the same. Everything else is the same as you see here. So it's just the frequencies of electromagnetic radiation that are emitted or absorbed. So we will do more questions on absorption and emission spectrum. Questions usually come in this way, okay? Okay, so let's leave it here for lesson 5. Again, thank you for watching. I hope that was helpful. Leave your questions in the comment section. And I hope we're together in lesson 6. Bye bye.